Hi, this is Srinivasan. Welcome to the day three of our 100 days challenge on agentic AI. Okay. So we are seeing the series of agentic AI, how it works and how it started and how the agent can be created. And some of the information we will be able to do some of the demos and the other informations. Okay. So this is a day three, and how it is just different from any other traditional AI systems. How it is unique, in its performance and also in its characteristics, and everything we will be going to see in this video. So autonomous agents versus traditional agents. So if you see the definition, right? The AI has come a long way, evolving the rule-based systems to advanced autonomous agents. The rule-based systems is nothing but, even though every algorithm, every machine learning is working on any algorithm, right? The algorithm itself, it is working on some rules and regulations, and that's how we are giving as an input, and we are testing, training, and validating, and each and every processes we are going to set it up, and then we are going to see any conclusion matrix for the accuracy, and it's not only the matrix, the conclusion matrix. It is not only for accuracy, how effectively we are going to reduce the error rate. It is very important for any kind of an autonomous agents. Okay. So one of the key distinctions in this evolution is the difference between the traditional AI systems and autonomous agents. Okay, so how well it is been adapted, right? So while both are designed to simulate aspects of human intelligence, just like how we are imitating the machines, or how we are just setting up some informations, to the autonomous agents, how it is just mimic the human brain or human activity, not only the neural network and the other systems as well, right? They differ fundamentally in how they function, learn, adapt, and interact with their environment. So in this article, we'll explore each and everything. Just not only an article, it is just fair enough idea to give about the agentic AI informations. Okay. So traditional AI systems rely on predefined algorithms and rules to solve specific problems. They are designed to follow a set of instructions provided by humans and are often limited to narrow domains. Okay. So this is very, very limited, and how the characteristics it is going to be, which is a rule based. The traditional AI systems work based on human defined rules such as if then statements or decision trees. So even some of the basic machine learning algorithms. Okay, so it is working on the rule-based engine. Okay, if it starts from this phase one, until end of the phase. I mean that's how it is the starting phase and the ending phase. And if the loop started, then until it will just it will go until the loop, end of the loop. So this is nothing but the rule-based engine. So no learning, they do not have the ability to learn from new data or experiences, because it has to, you have to give some of the training. I mean, that is why it is based on the historical databases. Without historical informations, you can't, the new data has not been trained, and the output you want to, what you expected. They function based on predefined logic and knowledge. It's already defined, right? Like how the pre-trained model works, the same way, the predefined logic, you can't change the logic, during the runtime. That is what they're saying. So single purpose, these systems are typically built for very specific tasks, such as playing chess, diagnosing diseases, or filtering spam emails. Okay, so any kind of, I mean, it works for only one thing. That is, you have to make sure that if it is very, very single, I mean, it is going to solve a single purpose, then you might, it might be traditional systems. And I mean, we have so many examples, in our day-to-day operations. And if it solves one particular thing, say for instance, weather forecasting, even the HR operating systems in a company, how to fix the salary for any employee. It is a single purpose, a single problem statement. It solves only for that particular piece of information. That's it. And then it will just, you have to, again, you have to train if it is a new kind of a data, and then only you'll be able to getting the prediction. Otherwise, your prediction might go wrong. And first of all, it won't work. Static. So once programmed, traditional AI systems do not evolve. So there is evolve means there is no further improvement or progress, or it could not be work as a user friendly systems. Okay, so it won't be online. I mean, online means the I mean, it has a restricted data, and you have to go and train again and again, and you have to wait for some time that kind of a model will get trained on the new data, and then it will come to the user interface, and then it will be used for the validation purposes or the prediction purposes. So it won't be like, even the chat GPT, if you ask any information previously, right, maybe 1 year ago, so it will give the responses until 2021. That means until 2020, it got trained all the in the informations or in the current political trends. If you wanted to get retrieve those kind of information from those LLMs, this large language model just got trained. But nowadays it is okay. Maybe a month, 2 months, even 3 months, until sorry. So until it is getting trained. It is more or less, it is coming along. I mean, the train it is getting trained very fast, so that you are getting you are getting new responses. Even if you ask any political events which has happened, within a month or within 2 months, it is going. Maybe you can ask the same kind of questions to ChatGPT as well. How well trained your model is. Okay, so if I share that information too, we can. So if this works, mm, do you give me the latest updates on um, current affairs? Let's check on what else it is good. Yeah, see, here are some recent updates in current affairs as of September 2024. We are also in September, right? And the national and political updates and sports. It is, it's almost, it is updating the world on sports, international news, science and technology, and it is really, it is wonderful. I mean, previously it was not like this because a lot of different GPTs and pre-trained models, it is getting, updated very quick, and you can do, I mean, I think it is really more or less very quick and it is getting updated very quick. Right. So in this example, the expert systems, one of the earliest forms of traditional AI, expert systems are rule-based systems that simulate the decision-making ability of a human expert. For instance, MICM, developed in 70s, was designed to diagnose bacterial infections, the mycin, right, and recommend the treatments based on predefined medical rules. It was highly specialized but lacked the ability to adapt a new medical knowledge without human intervention. So how it was, the system used a database of medical rules which were predefined by experts, because those rules have already been set, and it will be working only on those information. Okay. So it would take input like symptoms or test results and use its rule-based logic to suggest a diagnosis. And spam filter, you know how the spam filter this is working. Many early email spam filters, relied on traditional AI techniques. These systems use rule-based logic, and if an email contains certain words like free, win, or any kind of a promotional activities, then that kind of information will be it will solve only one purpose and just go with the traditional purposes and it is just always follow the rules. Limitations. While effective in well-defined domains, traditional AI systems struggle with tasks that require learning, adaptability, or complex decision making. So they cannot handle dynamic environments. This is what now the chat GPT is almost a dynamic, maybe 95% is dynamic. Dynamic in the sense it is getting trained on the current information as well, right? And we checked it right now. So they cannot, the traditional AI systems, they cannot handle dynamic environments or situations that fall outside their programmed knowledge base. If you are asking out of the box or out of their knowledge base, it won't get, you won't get any responses. Autonomous agents, how it is getting learning, adapting, and acting independently very quick. So autonomous agent is an AI system that can perceive its environment and make decisions based on what it senses and learn from its experiences, kind of learning from its mistakes and take actions to achieve a goal. So all without needing constant human input, unlike traditional AI systems. Autonomous agents are capable of functioning in dynamic, complex environments, okay, and can adapt to new information or changes in real time. Works in real time. That's what all the LLMs nowadays, so very competitive and compete enough to give informations for their users and subscribers. And every enterprises, they are trying to use their applications because of this. So the characteristics, learning and adaptation, right? Autonomous agents can learn from their experiences using techniques like reinforcement learning and deep learning. This allows them to improve over time and handle tasks in changing environments. Goal-oriented, real-time decision making, multi-agent collaboration, right? So self-driving cars. So it has to, update. I mean, if you are if you are in a self-driving car inside, and I mean, your car is driving, and it has to get updated, on real time. If it is not in real time, then there is no use of self-driving car, right? It has to make more decisions on the go, right? And self-driving cars like those developed by Waymo or Tesla are prime examples of autonomous agents in action. These vehicles are equipped with sensors, cameras, and AI systems, and we many know about the basic the functionalities, right? And self-driving cars use deep learning models to recognize objects like pedestrians, vehicles, signboards, and reinforcement learning to continuously improve driving decisions. Like steering, braking, accelerating, everything has to happen hand in hand, and based on real-time feedback from the environment and the decision making is like a quick, like how we are doing. Okay. So Google DeepMind's AlphaGo. So it is an autonomous agent developed by Google DeepMind, made headlines when it defeated the world champion in the game of Go. Unlike traditional AI systems that are pre-programmed to follow a set of rules, AlphaGo used reinforcement learning to teach itself optimal strategies by playing millions of games. This is what I was telling in one of the videos. If you just have if you are playing a chess game, it is the classic example of reinforcement. Okay. I think in the first video itself, I was talking about just a second day of this 100 days challenge. Just take a look at it, right? So the industrial robots, yes, obviously it is an autonomous agents. The form of robots are used for tasks like assembly, welding, and packaging. and much more. Wherever it reduces the human efforts and also increases its productivity of any manufacturing company or any kind of a logistic organization, whatever it is, right? And it just speeds up the delivery process. In those situations, we will be using autonomous agents. Okay. So the comparing autonomous with traditional, you know already what kind of things are happening. There is no human intervention in autonomous. There is a traditional. It will just follow a very simple process or a single process. And decision making is not quick compared to autonomous, right? So we have seen some of the examples and the use cases. So we'll be seeing during this 100-day process, we'll be seeing one of the each and every completion of the phase. Phases we'll be working on a demo of any agentic AI process, and you'll be learning a lot of things. But thank you so much for watching this video, and please follow for 100 days of this challenge on agentic AI learning process. Thank you. Thanks for enjoy the learning process. Thank you.